Okay, so then I leave it now to Rafael for the first session of the day. Thank you. Yeah, that's a good point.
I'm just waiting for the microphone. I think for this room it's probably okay, but I'm not sure whether the remote participants will hear or not. Ah, it's there.
Perfect. All right, so welcome also from my side. I'm Rafael Schmidt. I'm from the Bank for International Settlements. I'm currently chairing the SDMX Secretariat. So if there are any questions related to our secretarial work, please ask me, come to me. I mean, I know many here, but I also see a lot of new faces. So please, let's have a chat. I can give you more information about some of our SDMX secretarial work. So I have the pleasure to again welcome you. I'm very glad to see that all of you arrived safely here. Some of you from quite far away, from the US, South America, from Asia. I see some colleagues, Africa. It's very nice to have you all here. And I would also again like to thank Eurostat and Stats Netherlands for hosting us here in this beautiful location in Amsterdam. Now, I have the pleasure to open the first session on this exciting topic, artificial intelligence, which is obviously a very, very hot topic at the moment. And we have a special task given by the sponsors to look into this into more detail and to see how we can actually harness AI for, SDMX, for the standard itself, but also for the related processes, the data discovery, the data exchange, so everything what relates to our SDMX work. How can you actually use AI in order to make this more efficient and more effective? And just to give you an example, I mean, almost every institution is at the moment investing in AI. And just to give you an example, at the BIS, we launched half a year ago an AI working group, which is on ExCo level. And within 1 week, we registered 52 AI projects in the bank, in the BIS. And of course, we don't have the budget for all, but there's huge demand. And that's also what we can see in the SDMX world. Many colleagues are approaching us with proposals, questions. And we had a first session 2 or 3 months ago at the OECD to discuss how should we actually coordinate ourselves a little bit. What are the topics which we would like to, where we would like to co-invest together. And one of the big topics was data discovery, and that's actually the main topic of the first presentation and also the second presentation. And another topic was raised by the community who said, if you're an SDMX expert, then it's easy maybe to, let's say, understand, find all the information. But if you are a junior, a starter, a beginner, then it's really tough, to find the relevant information from all the documents which you have produced over the last 20 years. And one idea was, let's maybe try using AI to better prepare this information for newcomers. And what we did is a little, let's say, proof of concept using a retrieval augmented generation RAG setup where we loaded all the 100 SDMX technical documents, guidelines, etc. And surprisingly, the first results were very positive. And that will be today the topic of the last presentation, the fourth one. And the topic of the third presentation is another one which is at the heart of our sponsors, who actually tasked the Secretariat to invest a little bit more in making our standard interoperable with other standards. We're talking about other ISO standards, more XBRL, DDI, And that is something which in the past was always in the air, but it was quite hard actually to really find a translator or to bridge this gap between different standards. And I think one promising avenue is now with AI to actually realize this interoperability between different standards, because we can see this, for example, in coding and software development, where AI is used to translate large software packages which are written in one language, let's say R or SAS, into other languages like Python. And because SDMX and the other standards are very standardized, there's a lot of hope that we can also use AI for this interoperability question. So that's the topic of the third presentation. Without further ado, so let me introduce our first speakers. So Jeff from the IMF, and maybe just to give you some background, Jeff is Deputy Division Chief in the Statistics Department, and he's the Program Chief of the iData project. This is a project which modernizes the IMF data management and dissemination platform. And he is accompanied by Maxime from EPAM. EPAM is a software engineering and product development service company. And they both will present an AI application in the domain of data discovery. With this, I'm happy to have you both here. Please, over to you.
Thanks, Rafael, for the kind introduction. And good morning, everyone. Excited to be here. Excited to be first. We'll try and set the bar high. Don't see a presentation yet, so that's... there it is. Okay, again, my name's Jeff Danforth. I'm from the International Monetary Fund, here with my colleague Maxim Simisenko from EPAM. We're going to talk to you about this application. I think the hands raised, maybe you've seen early versions of this before, so this will be kind of an update of where we are and where we got to. Going to do a really quick introduction of the business case. What's the problem we're trying to solve with this thing? Kind of get you up to speed on where we are. We've had various stages of development, and we're sort of going through a beta evaluation phase now, so we can update you on where that's gone. Maxim's going to take you through sort of a technical deep dive, some of the issues we've had on SDMX side, IT side, as we've ingested more and more data sets into the system. Then I'm going to show you a quick demo of the application itself, plus a couple other tools that we've developed that are sort of related to the initial version, and based on some of the feedback that we've received so far. Okay, really quickly on the business case. So what's some of the problems we're trying to solve? So this image on the right is meant to sort of convey this idea of there just being sort of a sea of data out there that users kind of struggle with, right? So official statistics are published across multiple platforms, multiple agencies, and they're discovered using multiple tools. Each one of our organizations probably has its own dissemination tool. We have sort of our own data, even though we don't actually produce a lot of data, we just redisseminate data from other institutions. And users don't really have a good sense of where to go for what. And so I think that's potentially one of the advantages of consolidating this and having sort of an AI engine on the front end to be able to parse through the data. The users don't really care where the data is. They really just want to ask simple questions that cross multiple domains. We also tend to publish that data using statistical language, which is definitely not natural language. We say things like, gross domestic product at constant prices, and we say things like change in the CPI index. And sort of regular people, when they're searching things, they search for things like inflation or economic growth or living standards. And that's sort of a plain language type request that needs to get translated into this sort of official statistical language. And that's something that we think the AI is also quite good at. We tend to put official statistics in thematic tables. So we put prices somewhere, we put economy somewhere, we put education somewhere, we put demographics somewhere. And users don't really care about where it is. They really just want to ask questions across domains. And this last point, again, there's multiple versions of a particular data point. So take something like the GDP of Canada. That might get submitted to the OECD, it might get submitted to the IMF, it might get submitted to the World Bank. It gets redisseminated after some time, and so you have an immediate vintage problem. The official source of that data is Statistics Canada, but we redisseminate that data, and we may, by the time the user gets it from a particular source, it may be different. So maybe the data should just stay where it is, and we should just point users to the official source when we can. Okay, so where are we on the development of this thing? That top line is the project timeline. We started with a very early prototype in June 2023. We presented kind of a first version. Those of you who were in Bahrain at the STMX Global Conference saw sort of an early version. Then we had this meeting, Rafael, you mentioned it in Paris, the STMX AI, where we sort of talked about, okay, is this viable? Is this something we really want to proceed with? And the answer was sort of yes, and that's sort of where we are now. We're evaluating it amongst STMX sponsors. This has been live in sort of a beta version for about a week now. So we went out to STMX sponsor organizations. We asked for some testers. I sort of thought we'd get 10, 15, 20. We're at 90 now, so there's a lot of interest, I think, in this. We've had sort of 45 unique users go through the system. They've submitted, 430 requests. A lot of good feedback, a lot of requests for support questions. And then interestingly, sort of one of the issues that the sponsors are curious about is cost. So we've had, about 8,500 prompts, and the sort of per conversation cost is about 10 cents. So it's not super expensive, but again, this is sort of not optimizing that component. So that's definitely something we want to talk about. The usage stats are down there at the bottom. That spike was the day that we had the launch event, so that was our sort of highest output. Okay. Initial feedback. So we've received quite a bit of comments so far. A lot of this feedback actually points to some of the limits of the current version. So one of the things is being able to compare data sets across compare time series across multiple data sets. So currently, remember this system, and you'll see it when I show the demo, it's building an STMX query that it's using to execute against an STMX API. So it can't combine sort of multiple API requests into one request. Those of you who know Jim, this is his sort of like dream of having some sort of common data model across organizations, which is really what's needed to get to this, but that's maybe a step too far. Thinking about a way we could have sort of synthetic common set of data structures that we could query across data sets with one API. So that's something. We get a lot of requests about exploring more particular code list hierarchies. So, what indicators are there in Fred? Which countries are in this code list? It does fairly well with that, but when those lists get long, it struggles a little bit. This third point about processing queries like, get the misery index or give me data for a Phillips curve, it does fairly well. But again, there's this trade-off between asking the user, is this what you want, or what do you mean, versus going directly to the requests that the user's looking for. And that trade-off is a difficult one to balance. The other thing that this system, and this is part of what the tool that we've sort of built to address this comment, is it doesn't do well with sort of entirety of data sets. So if you say, give me every indicator in the WIO, or give me all counterpart countries for a particular data set in the TIVA data, for example, that's a really long list, and it sort of struggles with that. So then that sort of begs the question of maybe you want to pair this AI assistant with a standard sort of data explorer type functionality where you could just go back and forth between this sort of chat interface and a faceted search. And that's something that we're working on. So I'm going to pass the floor to Maxim, and he's going to walk you through some of the STMX.
Great, thank you, Jeff. Hello. So when we started working on this challenging task, this was important for us to actually prove that we can combine the various data sources from various agencies. And we've been successful in joining together 8 data sets from 8 different statistical organizations with very different structures and approaches to how you model them. So the list is on the right. You can see the organizations and the data sets. And just from this list, you might see that they are quite diverse So you could see the OECD data set, TIVA, which would be having the counterparts country, and you would have other data sets that would not have this. And we clearly see that there are various approaches to how the data is modeled by various agencies. So you could have packed cases, unpacked cases when you have one large indicator, or you have multiple dimensions that would outline your indicator. Or you could have some data sets, particularly for national agencies, would not have the country dimension, just for the reason that they do not need it. It's evident that statistics of Canada would be just given data for Canada. Clearly, very, very, very different approaches how you model your metadata, how you enrich your data with some metadata. This is very different within all the organizations. And the concepts are also not harmonized to the like level when it would be very extremely easy for us to use it. So those were the challenges that we were facing. I will talk on the next slide how we were approaching them. On the IT side, so the data that we've been plugged into the system, we see that there is different level of compliance to SDMX standard between organizations. We also see, and we've been asked to add a few of the data sets that do not even provide the SDMX interface to them. However, there is still a requirement to search for this data. So what we did, first we thought what would be like the mandatory ask for you about the metadata, and we wanted to minimize it just to make it as available as possible. And for the artifacts, we really outlined just one mandatory requirement, which would say that we want your names for your codes and your code lists to be available and comprehensive. This is the must, because this is how we can actually utilize AI to do this semantic searching. The rest, there are no other requirements at all. For the registry, there are a bit more. So again, we tried to be flexible. So we use 2.1 versus 3.0 any, JSON, XML, both supported. So we have several structures that your registry needs to support. Obvious are the chain, data flow, DSD, concept scheme, and code lists. And we also use hierarchical code lists or hierarchies in the later standards to code the groups. So whenever we have the concept of groups, for instance, you can say what are the statistics for G7 countries. This would be decomposed to actual countries or members of G7. For this, we use hierarchical code lists. We use data query. This is obvious. We use data availability query. This is important for us to know what data you really have to give to the user, only the valid combinations. However, it's clear that we had to extend this meta information a little bit, and this is the block on the right, and this is quite simple, I believe. We tried to make it as minimal as possible. So what we add on top of what you already have, which metadata we enrich your data with. So first we give the ability to override the title. This would be this second line there, just for the reason that we probably want them to be harmonized in a sense when they are presented in a single database. Then we use the citation source, which would give you the credits for your organization. Official data source, whether it's official or not, we show this like showing the star mark near the official data source. And then we also want to know about the dimensions. So we have a group that would outline what would be the indicator dimensions. If it might be one or several, so this is an array here. We want to know what is the country, what is the frequency dimension, what is the time period. And we also introduced the concept of virtual dimensions. This is to address the case when you would have the data set per country or the data set per indicator. So this, you would not have this dimension in the data sets. So we can just give static values to it. And so now how we address the technical parts of it. So first we just taken into the account that there might be compliance issues with the registries that we have today. On the left is what we have now. On the right is what we foresee to have in the future. So now we have just one master registry into which we loaded all the data. So blue arrow stands for the SDMX replication. So if you had SDMX interface, we just use this to get the data to our registry. If this is red, it stands for non-SDMX replication. So for this, we had to do some modeling and to provide the SDMX dataset. In future, we clearly see that master registry might stay to address the cases when the agency does not have the compliance API or when they still do not have the SDMX API. However, we also envision that there might be direct connections to the registries that are compliant with our requirements. And a few simple facts. So the LLM that we are using now is GPT-4 Turbo. The cloud in which we can be deployed is any. So we are deployed on AWS. We also have successful deployments on other clouds. And the operation language currently is English. And here I pass the word over to Jeff to talk about the tools.
Thanks, Max. Okay, so just coming back to the tool set, and I'll take you through the first three at least. The chat UI is sort of the standard one that we've seen before, and I'll try and go quickly through that. And then to address this idea of having a faceted search in conjunction with a chat interface, I'll show you a sort of add-in, an Excel add-in version and a sort of Dataset Explorer version. And then if we have time, we can show you some of the administrative controls, where the sort of back end is, where the data set ingestion is, and maybe a little bit of the analytical dashboard that talks about usage, cost, all of that stuff. But I'm going to look at you, Rafael, and you're going to start giving me the evil eye that I'm taking too long. So I'll try and be quick. Okay, so let's go here. Okay, so this is the. Yeah, you can see. Okay, so this is sort of the standard chat interface. If you're familiar with ChatGPT out of the box, this will look quite familiar. You've kind of got your interaction in the middle, and you've got a list of your saved conversations on the left. We think of this system as being very approachable in terms of a conversation that a user is going to have with the system. So you might ask this question when you come to the system, and you might say, hello, what can you do? So I don't really know what this is. I don't know how it works. Please kind of explain yourself, and you'll get an answer like this. Hello, I'm here to assist you with a variety of tasks. And this is sort of introducing the idea of agents, which is sort of inherent in this construction. So the sort of three main agents that are in the background here is the available data sets. This is just the catalog agent, if you want to think of it that way. A generic question agent, which is really asking, answering questions about knowledge-based content. So these are sort of generic questions. And then sort of the main one that is really extracting the data is this metadata and query agent. And really, there's actually an agent on the top who decides which agent to use. So there's agents sort of all over the place. So you might have a sense of what it is that you want to do. You might say, oh, I don't actually know which data sets are available, so you could just ask. What data sets do you have? This is reproducing the list of the data sets that Maxim showed you. These are all the ones that are in the system. The stars that Maxim mentioned, again, this sort of gets to that vintage problem. We want to identify official sources where possible, so that if someone's looking for GDP for Canada data, they know that the official source for that data is Statistics Canada, so we put a sort of star there as an official data source producer. The IMF, Eurostat, OECD, World Bank, ECB, and BIS are all in here. I won't go through individual data set type queries, but in this implementation, we have this sort of conversation catalog. And so for those of you who are in the testing group, you'll be able to, you can access all of these conversations and go through each of the sort of targeted ones for your particular data set. I sort of won't go through those now. Maybe just, this is a conversation I was playing with the other day, kind of sort of demonstrates this idea of going back and forth between learning about data, which is not easy to do in a typical faceted search. If you wanted to ask a sort of generic question about in this case, the Phillips curve. If you think of any of our data set portals, it's not that easy to ask a question like that. I mean, you could go to Google, but then, where do you get the data? You sort of go down this path of figuring out the data. This system tries to pair those two things together. So you ask a question about the Phillips curve, you learn something about what it is. You say, okay, I think I'm a bit more educated about the Phillips curve. Which variables do I need to calculate it? It sort of tells you, well, it's the unemployment rate and the inflation rate. Here's some additional considerations. And I say, okay, I'm convinced and I really want those variables. All right, well, give me the data that I need to calculate this. And this is really a switch between this generic question agent that you see listed here and this metadata and query agent, because the system recognizes that this is a question about data. So this is a request to get data out of the system. Now we have a bunch of data in there, and this data exists in multiple places. So it's natural now to ask the question to the user, well, where would you like me to take this data from? And so it's found two sources for these indicators, the World Bank and the IMF. And I didn't use the IMF. So I said, okay, use the WDI and go back 40 years. Now remember, any of the dimensions that you're putting together for this STMX request, you can alter using this chat interface. So in this case, I altered the time dimension and said go back 40 years. And now it's produced a set of outputs. That's what's in these attachments here. This data is really just a rendering of a table. Those are the three indicators for Japan. It found the unemployment rate, inflation, two different sort of time series for the unemployment rate. I won't go through sort of all the charting here, but inherent in this system, remember, is this is not asking this interface to find data. What really is happening in the background here is this interface is building a query that you can execute against an STMX API. And this is something that we've implemented to really get around this issue of hallucination. If you use ChatGPT and you say, build me a table of inflation unemployment rate for Japan going back 40 years, it'll sort of do its magic, it'll populate this table, but you don't really know the provenance of that data. You don't know whether it's all from the same source. You don't know a lot of things. In this case, what we're saying is, well, build me an STMX API query that queries data for Japan unemployment rate and inflation. And when that query is executed, and this is the query itself here, it's just querying the World Bank's STMX API. So this is the query itself. And at that point, assuming the users said, this is what I want, you know that that's the data that's coming out of the system with certainty. So one of the things, and this comes back to a little bit of the feedback, this is 3 series. It's kind of easy to see in a table. You can download this into CSV. You can chart them. But you might want more data. You want more data for countries. You might want to put some countries on a particular, graph them all on the same chart, and do some more sophisticated things. And this really gets to this feedback of, what if I want to start here, but I want to expand in sort of a data exploration manner? And so that's one of the things we've worked on in sort of this implementation. So this is really a chat interface that's integrated with a dataset explorer. So this interface here is the exact same one that I just showed you. And in fact, it's literally the exact same implementation. So when it produces data, it's actually producing all of those same charts and attachments, which of course when you have the dataset explorer you don't need, so that's something we can work on. But at the end, when you've gone through this is a simple question, give me the GDP for France and Germany, you're going through, again, it's asking you which source you'd like to use, you're choosing it, you're doing the exact same interaction, the exact same conversation, use the World Bank, it's sort of found it, but when you hit query data, it dumps that data out into this dataset explorer. And the advantage of that is, whichever dataset explorer implementation you have, this is ours, but it could be any, then you can use all of the data explorer functionality. So you could put 2 charts, you can graph these 2 charts together on a line, compare them, download them, whatever sort of implementation you have for your dataset explorer. And the nice thing here is, really, because a faceted search execution is just the same execution of the STMX API, whatever you've chosen here is replicated in the data set itself. So if you have France and Germany, I would expect here when you find the data set is the one that we are talking about, you'll find the countries, the series, they're all selected. So then if you want to switch to a sort of faceted search, you could just grab a few extra time series, grab a few extra countries. You could do it in the chat as well, but it's sort of interoperable between the two. So we think this sort of gets to that issue of, well, what if I found the data set, this looks good, but I want everything from this data set. You could just come to this sort of standard data set explorer and extract everything out. Similarly, the sort of exact same implementation, but in Excel. I know in the IMF, this is sort of the primary mechanism that data is extracted from our system. Again, I think that having this chat interface embedded in an Excel add-in type functionality will be really powerful. People don't really know where to look. They don't know, what's in what data set, and this sort of chat works to help them. And once in here, you're just adding to the worksheet, you embedded it in your worksheet, and then it's refreshable because it's just a repeated call against the STMX API. So you found the data that you want. You don't want to look for it again. You're going to download those same 10 series every month when you update your forecast. So you just come here and hit refresh. How am I doing on time?
3 more.
Okay. All right. So maybe I won't show the other tools, and I'll just kind of go back here. Talk a little bit about next steps. And I'll throw this QR code up here because I said we had 90 participants in this testing phase, but we could always use more. So if you want to add your name to the list of testers, please do it. That's what the QR code should do. Send you an email, or you'll send an email to us. So what we'd like to do, like I said, we've been doing this testing for a week. We maybe have 2 more weeks of testing, maybe 3. We'd like to add that data browser and the Excel add-in to the testing functionality to get some feedback on that. So we plan to do that maybe by the end of this week. We'll go through completing this evaluation stage. We'll send out a survey to all the testing users. And then we really need to convene, I think, as STMX sponsors and sort of say, well, is this viable? What do we do next? Co-investment, whatever the future is. And the basis of that discussion will be a report that we'll put together following the feedback. So, thank you.
Perfect. Thanks, Jeff. Thanks, Maxime. All right. I think we do the following. If we have time maybe for 2 questions now, and then I would actually like you to just keep the other questions for the end. Then we have a little bit longer discussion around at the end. So is there any, let's say, question at that moment? Yeah. Matt, please.
Do you need a microphone? Maybe. I don't.
Yeah, there's a microphone on the way.
Come on up, Max.
Thank you. Thanks for the presentation. It's really interesting. So my question is on one of the points was the code name has to be kind of informative for it to work nicely. So my question is on the difference between data structures with fewer dimensions but very long code names versus data structures which are highly multidimensionalized where the code names are very short. Do you see an advantage in one over the other when it comes to AI and search?
Well, I'll start and then Maxim can fill in the details. This is an interesting question, and I had that same question about, take a global DSD, say BOP 17 dimensions versus say ECOFIN 3. Is there an advantage or disadvantage to the AI system? I think the answer is no, but what really matters is how good the metadata is. But Maxim, correct me if I'm just misspoke.
Right. So we actually tried to accept the reality in a sense that data is modeled differently, and so to the extent to which we advanced is that we really have this concept of the PACT indicator when we will be either taking the PACT indicator by itself or we'll be combining it from multiple dimensions. So at this point in time, I adhere with Jeff that there is no particular difference in performance, and we can quite well work with both types of the data sets, either packed or unpacked.
Okay, but from the meaning perspective, when you're actually doing a search, it can understand enough about what you want to construct a meaningful query, even if it's highly multidimensionalized.
Yes.
Yeah.
Yeah, I mean, I can show you, I think some of the, like the TIVA is a good example because it's got a lot of dimensions. Let's see if we can find a, yeah. So if you, well, we don't have the extraction, but, oh no, maybe it's here. Yeah, so I don't have the data set extraction, but if you need to populate the dimensions in order to execute this query, but you can, it's maybe a longer conversation. For example, in this data set, you need to assign a counterpart country. And so I think the question is, well, do you have to set a counterpart country default if you only pick one country? And do you tell the user, oh, actually, you need a counterpart country for this data set because there is one? And we've erred on that side of going back to the user with sort of the results of their preliminary query. So if there isn't enough information in what they've given you, we will go back and say, well, actually, you need to. But this question of defaulting to a particular thing for dimensions is another interesting point. Yeah.
Okay, perfect. And we have time for one more question. Jonathan?
Thank you for the presentation. Just a question. I didn't see there anything about quality, so I'm wondering how you're measuring that and accuracy of the results and how that may be improving over time. Especially, I mean, you talked about in TIVA, for example, you have the reference errors and the counterpart country. How does it differentiate between these things easily? And even within organizations, we struggle sometimes to harmonize. So, yeah, I'm just wondering if you can talk a bit on that.
Okay, so this really, here I believe we show something that's we prepared but did not include into the main presentation. So this is the reports that is generated by our tool, and the way we approach it is quite classical approach with how you test the GenAI applications. So we have the test data set, which would generally combine the questions that your users would be asking and the expected results for them. And we only focus here on this retrieval part when we categorize all the concepts within the original requests, and then we expect to have them in the final outcome. Because once we have it, once we build the structures query, we do not need to test that one. That one is very deterministic. So we have a number of test cases. It could, of course, be enhanced, but so far this is 130 test cases on various data sets. And we have this mapping where we will be checking ourselves with the expected results. Again, the presentation that I assume will be shared afterwards, it has some slides on this topic in the annex section. So this, we took these pictures literally from the Wikipedia. We defined two metrics, precision and recall. One stands for whenever you get the results, how many do you have false positives into the results, or something that you don't expect, but you have this in the results. So we check this one. The other is how many of the false negatives did we leave aside. So precision stands for the first one, recall stands for the second one. The closer to the one is the better. And the current metrics are quite good. So they are 0.72 for precision, 0.82 for recall. We have, and we constantly working on improving those, and we are monitoring that any of the change that we introduce into the system does not give us a regression over those metrics. So this is the approach that we are taking to track that we are actually good on those metrics and not introducing any regressions with the changes either in codes or changing the model. We also will be checking ourselves through those test cases.
Okay, perfect. I would like that everybody remembers the question for later, so you have enough time at the end for the other questions. Thank you both again very much for this inspiring presentation, which is fully in line with the, let's say, collaborative spirit of SDMX. Looking forward to the next phases and the test results. All right. Then our next speaker is Alex from a company called SEAS. He is working with BS Together and also has worked in the past with other sponsors on similar, let's say, topics, data discovery, improvements by utilizing AI. Now, the focus here is a little bit different because many of our institutions actually use search engines such as Solar, for example, to store information and retrieve information. And Alex and his company is actually specializing in especially this domain, in the Solar domain. And he will present today the findings of our various proof of concepts we have done over the last couple of months. Over to you, Alex.
Thank you, Rafael, for the nice introduction. So I'm going to skip this slide because I've been introduced already, and this as well. So we are open source enthusiasts, the key takeaway from here. So we work with open source, we contribute back to open source, and we work with information retrieval and artificial intelligence integrations. So today we are going to talk about a use case, which is stats navigation, and then dive into moving from natural language interactions to structured queries. Explore the findings from the proof of concepts we've developed and the road to productionize them. So let's start from a very quick introduction about large language models. They are basically powerful autocomplete systems. They are pre-trained on vast amount of data and then fine-tuned for specific tasks. The large language model usage we're going to see today is more about following instructions as a task. So they are instruct-based large language models. So they are fine-tuned to be able to respond to specific questions called prompts. Search engines for many years were just based on keywords, so just based on terms. They are called lexical search engines, and they present various problems. For example, the vocabulary mismatch problem, where the terms used by the user in their queries are different from the terms used in the documents. So sometimes you get documents that don't really match the user information need, or sometimes you don't get documents, so you have false negatives. So you don't retrieve documents because they were using different terms to express the same information, the same meaning. And in regards to semantic similarity, sometimes you have the same terms that express a different meaning, like how old are you or how are you? So a huge overlap of terms, but completely different meaning for those questions, or the opposite. So you have like different terms, but the meaning is the same. How old are you or what is your age? And this ambiguation as well has always been a problem because sometimes, depending on the context, your terms will mean something differently. And over the years, there's been like many solutions, many lexical solutions for this, like manually curated, so like synonyms. You can express like the relation between words, like generalizations with hypernyms or specifications with hyponyms, but it still is manually curated. So maybe your organizations have like list of synonyms. And of course, they are hard to maintain, expensive, they get out of date really easily, so not really a solution that can be maintained and used. Or algorithmic solutions, of course, these are vastly used, like stemming, lemmatization, so brings words to the root of them based on algorithms, but we can do better. So can we use large language models to parse natural language, so expressions, into a structured query? So can we move from PM10 levels produced by industries in the European community in May 2015 to this JSON representation, where we have filters selected with dimensions on the left and dimension values on the right? So this is a real case application, and we have been working with SDMX sponsor organizations to exploit large language model in order to disambiguate the meaning of a user natural language query, extract the relevant entities and concepts from the query, and then use the extracted information to run a Solr query in these specific instances, but in general, just a structured query. So it can be a database query. So what's the architecture of this proof of concept? So we have the search API, that's the input. So that's basically where the user inputs their query. And then we have access to a large language model that is going to parse the query and bring back a structured query that then we execute against Apache Solr. For example, Apache Solr is an open source search engine by the Apache Solr Foundation built on top of Apache Lucene. To interact with the large language model, there are many libraries. One I mentioned in here is DSPY from Stanford, but there are alternatives like Haystack or LangChain, and all of them are open source. So the first step is to retrieve the domain, so retrieve the way information is represented in a structured way. In here, we retrieve this information, so the topics, the dimensions, and the dimension with values from the Solr index. This is just to make sure we are as close as possible to the data in the search index, in a way that when we query the structure query against the search index, we are aligned and we find documents. But of course, this stage can be also, again, like extracted from the database. We get a query from users. So the first step, of course, we don't need to repeat it every time. We just need to repeat it periodically to make sure we are aligned with the data on the search index, so we can potentially cache it. What were the sulfur oxide emissions in Australia in 2013? So we take this query, and then we interact with the large language model in the following way. So we provide in input the user query and the representation of data, so the dimensions and values we previously retrieved from our search engine. We are basically telling the large language model, this is the way we represent information. And then we ask the large language model, given an input the natural language query, can you represent this query in the object representation I provided you with? And then some formal requirements, like we want the output to be, again, in JSON. We want to extract one value for each dimension, and these sort of rules we want to add to the request. So this is the part of filters extraction, because the output of this task is effectively a list of filters where the key is the dimension and the value is the dimension value. Something like this. So like a topic, in this case, environment and climate has been extracted, and this is actually real data from the proof of concepts. Country, Australia, with the code. Variable, total man-made emissions. Pollutants, sulfur oxides, and here, 2013. The original query was what were the sulfur oxide emissions in Australia in 2013. Then, from the structured JSON representation of our filters, we can build the Solr query, we can build the database query, we can build actually whatever interaction with SDMX data we want. In this case, it's just a Boolean query with OR operators in Solr to retrieve time series, but can be pretty much anything you like. Then we execute the query against the search index. This can be, again, something behind the scenes in your data explorer, and get back the search results. Findings. So what was the results of these POCs? So let's start from model considerations. For this proof of concept, especially the last we did, we used GPT-4 as a model. The investigation of the model was not part of the proof of concept. So we basically did like a lightweight evaluation of different models. We ended up with one of the most popular, and this is no way the best right now, of course. I mean, this was 4 months ago, but if you, of course, go to production, I strongly recommend to do deep evaluations and comparison, because potentially you may want to undertake some additional fine-tuning of those models to adapt better to your data and to the specific task of extracting entities. So promising aspects. The overcome of the lexical matching problem, even using just a default out-of-the-box commercial model such as GPT-4, was extremely positive. So you could express a natural language expression such as the land of kangaroos and country Australia would be recognized quite easily by the model, or tobacco consumption and identifying the topic smoking risk factors for health without any fine-tuning. So literally just using the model out of the box. And additional promising aspects was the explainability side of things. So given an input, a query such as cost per square meter for family houses in Italy, we want to select filters, but can we explain those filters? Can we also give users like a rationale of why those filters were selected by the model? This can be really useful because the user will be able to understand better why certain filters have been selected. And these are the elements segmented from the original query by the model. Cost per square meter has to do with pricing or valuation, so price unit was selected as a dimension value. Family houses is a type of property, so real estate type was selected for this element. Italy is a location, so reference area or borrower's country could be selected as a dimension. And the rationale from the large language model is something like this. So we need to identify which dimensions and their corresponding values are the most relevant to the input text cost per square meter for family houses in Italy. To do this, we will look for dimensions that are directly related to real estate, housing, or geographic locations, specifically within Italy, and so on and so forth. So this can be actually quite useful to motivate the structure filter selection. So out of this, we got an idea. So can we use it not only transparently, but also explicitly to help users navigate stats as a sort of assistant that guide the user in the selection of the filters with the explanation as well. So not only suggesting filters, but also expressing the motivation in the way that then we can collect potentially additional feedback from users, like, is this motivation nice enough? Or sometimes it's very likely that the large language model can make mistakes and we can learn from these mistakes. And we got actually good results in using this, in viewing the proof of concept from this perspective. And nowadays, we also experimented that the implementation was quite straightforward in comparison to what would have been developing this kind of task 3 years ago, for example. And models out of the box actually ended up being quite good already. So this is absolutely a promising aspect. There are limitations as well, functional limitations. So an out-of-the-box large language model is not necessarily always right, so it's not always identifying the right entities and the right concepts and linking them to the right elements in the taxonomies. So this is a problem that potentially can be solved with more modern models or fine-tuning these models. And then there are formal limitations we experienced, such as the weakness in complying with the problem definitions. So you may require the model to select one element from a taxonomy, so one per dimension, and I don't know, like 5% of the time we get 2 elements out of a dimension, potentially. So not respecting the formal definition or the output format. So we wanted a specific format like a JSON structure, and sometimes we got a JSON plus Java comments to explain why an element was selected. And of course, if you plan to use this automatically, like programmatically, you don't want a comment to be there. JSON doesn't really support comments, or anyway, they won't be useful in any way. And to solve formal limitations, there's this need of exploring more ways to program large language models rather than ask and prompt large language models. So we are going to conclude this with the road to production. So what does it mean to bring this proof of concept to production? So the first step is design the user experience. So do we want this to happen behind the scenes in data explorers and then potentially build a retrieval augmented generation snippet where you basically summarize the results and respond in natural language? Or you want to use this as a filtering assistant, so something like on top of your current experience, explicitly showing with a disclaimer like, oh, the large language model can be wrong, this agent can be wrong sometimes, but these are the suggestions for your filter selection, and this is the explanation for these suggestions. The following step is to, if you want to bring this to production, is to select the best model to date, so compare different models, hopefully open source models where possible, and potentially fine-tune the promising model for this specific task. Because using large language models that are fine-tuned for instruction following may not be the best usage. Maybe you want to fine-tune a large language model for this name entity recognition and linking task, or potentially use other models such as Gliner, for example, which is already fine-tuned for this task. Then if you are stuck with like a instruction-based fine-tuned large language model, you should refine the prompts depending on the model, so to make sure that we reduce the functional and formal errors. Then we need to implement integration tests that assess that certain situations are responded by the system in the expected way. So we want certain queries to be parsed in certain ways, and study additional libraries to make the prompt more programmed rather than just asked to the large language model. So we don't want trial and error. We want to make sure that if you express, I want a JSON in output, we get a JSON in output. I want to make sure if I express, I want one element from each dimension to be selected, or 0, we want to see that happen. And then stress test the solution to monitor the resource consumption from the point of view of hardware, resources, or money, of course. Finally, quality evaluation. So set up queries and expected documents to make sure that the system is behaving functionally in the way expected with the right level of quality. So you can monitor precision, recall, and also like ranking-based evaluation metrics, and so on and so forth. And that's it. That should be in time, Rafael. And thank you very much for your attention.
Super. Thanks, Alex. Very, very interesting presentation. So again, we have time for 2 questions, and then we ask the other questions later. Maybe let me just break the ice. Alex, one question, because I don't think everybody is familiar with Solr. Yeah, and you said, yeah, it can be Solr, or it can be any database which you query. So can you maybe just give an explanation? When would people choose Solr? What's the advantage, and what are the use cases for this? Yeah.
Sure. So Solr is an open source search engine that is ideally used for free text search. And if you want to make like a structured query with some flexibility in terms of like it's not, you don't just want to match an exact element, so you don't just want to match an exact match with your items, but potentially you may want to search the title as well, and content like free text content. Solr can be an option. Many data explorers are implemented behind the scenes using Solr, also because Solr offers you not only searching capabilities, but also like navigation capabilities, exploring of statistics and facets over the data. So this gives you the ability of seeing filters with counts and then potentially refine your search and basically deep dive into your data and explore it from different angles as well. So that's another positive aspect. And can be Solr, can be competitors such as Elasticsearch, OpenSearch, but Solr is fully open source by the Apache Software Foundation, so this is one of the reasons it's one of the most used nowadays. And has been there for many, many years. So it's also quite a solid software.
Okay, perfect. Yeah, for example, also in the BIS we use it behind the scenes of our public data portal. And also I know other organizations, the OECD is using it. Yeah. So if you have further questions, please approach ADEX or one of those organizations. Jens, please, next question.
Thank you for the presentation. My question is about the usage of the approach that you have proposed. So you say that you can data mine query filters with this. Would it also be possible, or instead be possible, to data mine dynamically generated synonyms, so that you do not pre-select facets in this approach, but you fine-tune your free text search, and so you return the data through dynamic generated synonyms?
To a certain extent, this is what happens behind the scenes, because we ask the large language model to automatically generate synonyms without specifically asking. So what I expressed in a funny way with the land of kangaroos and identifying Australia, for example. So the large language model already is able to recognize that pattern of language as semantically similar to country Australia, and we are matching the taxonomy element, country Australia, without even having to define the synonym explicitly or automatically. So it's basically, in our index, we have country Australia. So it's like asking to the large language model, can you direct all the terms that have this meaning to this root representation of the information? So potentially, and this was actually part of the POC with OECD, we use it to expand the query, can you represent this query in different ways and then run against a description, a title, and this kind of thing. So that's another way that can be used. But yeah, it's not even necessary to explicitly generate synonyms and maybe store somewhere, because we can do this on the fly. Hope this answers your question.
Okay, perfect. All right, thanks again, Alex. I'll give him another clap.
Thank you.
All right, so before we start the next session, I just wanted to do a quick technical check. Samuel, who is actually one of the presenters who is remotely logging in, is just online with Zoom. Can you maybe just turn on your microphone and check whether it works? If it doesn't work, then he has 20 minutes to find a fix, yeah? So Samuel.
Hello, can you hear me? Hello from Germany?
Yes, it works, yeah? All good.
Perfectly.
Okay, very good. Super. Okay, so our next speaker is Tom Roberts. Tom is the director of a company called SmartX Data. And he will talk today about what I mentioned at the beginning, about using AI to support us in the interoperability question between SCMX and other standards. And before Tom starts, maybe just one sentence regarding his background, which is quite interesting because basically Tom is working for a company which tries to implement a global exchange, which is transforming data into a tradable commodity. So I think this is something, Tom, you need to explain a little bit more in detail. Yeah, I think. Yes, it's probably more complicated than SDX.
So SmartX Data is building an exchange. We had an idea that data is a commodity. Okay, it's a new asset class. But the problem is there's not been real true price discovery in a regulated exchange. Think of stocks or bonds or anything. You go and you buy, you know what you're getting in a regulated kind of environment. So SmartX is creating that entire platform. Exchange, tradability, price discovery, bid ask, all built into the system with KYC, AML. And of course, we've got SDMX. We're actually an agency with an SDMX and do our best to promote the standard where we can.
Okay, very good. Thank you.
So, because Glenn kept telling me 15 minutes, I'm timing it here. So when I got this task initially to come up here and talk about artificial intelligence, of course, we all know it fixes everything. And if it could fix SDMX, I was going to be really, really happy with it. But SmartX Data has an issue in regards to where we have to have a common kind of a catalog. So if the data is, in our world, it's hot or cold data. I know you guys are calling it microservice data, but it's hot or cold. Hot data is it's being generated from an IoT device, or it's some other type of device that's in your home. Then the cold data is what's been produced, but you might want to look at it in 6 months or 12 months down the path. So one of the bigger standards that's out there is ISO 20022. You all know it. You deal with banks. Obviously, your banks, of course. And we were looking like, okay, how do we get the ISO 20022 data to start to come into the SDMX format? And that's when the fun started. This kind of says that, you know, I had the idea of, okay, can I take the power that is SDMX, that you all know about and most people don't know about, and somehow integrate that into the world of bank messaging types, to where they have a specific mandate to get things from point A to point B with the messages they create. You guys is everything else. It's the enrichment, it's the understanding, it's the in-depth that can happen. So we started looking and I said, hey, could AI fix this? And that's when my pain started. We said, okay, how do we get there and what are the realistic goals? Where can we, and what can we do to take, if you look at ISO 20022, excuse me, it has 754 message types to send money, and that covers the entire gambit. But also within it, there are substructures within substructures that kind of make it challenging, but looking at what SDMX has, it was kind of they kind of were working very well together. And looking at, okay, so what can I do? I can't, everything about standards these days is, okay, I want you to come over and convert to my standard. And I took a different approach, said, okay, what can I get out of that standard that we can bring into SmartX Data to help out? And also gain some insight, because besides trading the data and determining the value, there's also abilities to trade the insight. You guys are finding things that people don't know about, well, that should be sold and moved on in a commercial standpoint. So in looking at the realistic goals and in looking at the previous two presentations, it's not easy with ChatGPT. The training that you have to do, hallucinations aren't even the starting point. The things that it was coming up with, we didn't quite understand what was going on. So the realistic goal is, okay, what could we take and port and show that this could actually work? And before I get there, I wrote an article about 3 months ago called Peanut Butter and Jelly Moment. Some of you may have read it, where how do you take these two great things and make a peanut butter and jelly sandwich as I saw it. And with that, it sparked some interest from the 20022 crowd, and I'll come to that here later in the presentation. But this kind of started us down this AI kind of path here. How do I take these two standards that are super powerful, that are globally dominant, and bring them together to actually create something that we can leverage the strengths in a more cohesive ecosystem? So we started looking at large language models, and by the way, I like to call them now large action models. I'll come back to that in a moment. It has an ability, it's really efficient, and by the way, we tried the different chat GPTs. Actually, I like 3.5 personally. to see what we could do to start pulling in some of the metadata, the models, the things that were inherent to 2022. So, by the way, that was generated by AI. I forgot to put that up there. So we said, okay, let's look at the bank identifier codes for ISO 20022. And we worked with, and it'll come back to the team here in a minute, we worked with a tool that's been created by another company, Pierre, and it's Alphine's the name of his company, that's taking, kind of like Project Keystone's trying to do, where it's taking all of this disparate data and it's streamlining it through what he's calling a Swift flow at this point, to where we've got it to where we were able then to put it into ChatGPT to get the bank identifier codes into the SDMX format, which allowed us to do some other things. Here's kind of a walkthrough of really what was happening. Again, porting from the current ISO messaging type, which is ISO 15022, into a more streamlined version, so it adheres to the new standard. We started talking and having fun with ChatGPT. We were able to get it to output finally, to which we were able to, with Glenn and Matt's help, we're able to get it into the FMR. So we were able to get through the process, again, on the short timelines that we had, we were able to get, okay, we can make this work. And this is kind of the validation kind of stuff. You can see where we kind of went through some steps. Was it perfect? There's still some work that needs to be done. I think with any of us, we'd all say the same thing. Is it promising? Yeah. I think one of the things that the previous two speakers spoke about was the NLP side. The slangs, what you guys talked about earlier is so very true. And looking at the queries we're trying to do from an NLP standpoint and the complications that lie there are really the challenging points for us. The AI has the abilities. It's being able to get the correct kind of, we're used to kind of, search engines kind of thing. Now we're trying to talk it. I want to kind of go through these next two slides. Does this go backwards? Oh, it does, good. I wanted to go to here, and it's kind of odd to put the people that worked on this thing, but it's important because one of the things you guys keep talking about, and ladies, excuse me, is interoperability. It's getting all of you to start talking. So when I wrote this peanut butter and jelly thing, all of a sudden the TC for 68, the financial services, Jim North, he goes, who the hell's Tom Roberts? And what the hell is SDMX? This is a guy with the largest financial transaction messaging type that Bank for National Settlements, and all of you guys, he had no clue what you were doing. So when I finally got his attention, he turned me over to Chris Day and to Jason Pullis, who are two of the core, they're kind of like your equivalent of Glenn and Matt, who then turned me over to Dr. Pierre, and there's a point I'm getting to this, who then I got AI guys to come on board from Modulus. I got Raul to come on from University of Chicago. And the reason I put Jan Pokop up there, you always find the oddest information at the times, but he was talking to me about, well, how do I use SDMX? And I went, what do you mean? He goes, well, what's it going to do for me? And I went, that's a great question. And I couldn't answer it. And then I started, well, wait a second, there is some benefit that could come out of this. How is it helping economies, governments, and stuff like that? And I kind of got him to understand better. But the one thing, and the reason I put him on there, he goes, how do you create a natural language query that's going to give you what you need? And I said, there isn't a magical query for that. But he kept kind of poking at me to make it do. And then, of course, Matt and Glenn. Kind of going towards the future stuff, we're all looking at large language models, and those are important, but now the models are getting aggressive. They're billions and trillions, and they're all of a sudden they're going to go outside of the room they're built in. The models that we're looking at and the future potential for stuff that we want to do are taking the models and actually squishing them down. So there's one general model, but then you've got very small or tiny MLs doing a lot of stuff right now, to where you go, okay, I need specifically these things to do that. And we did some quick testing, and we found there was some results if you were break the thought process down into specific MLs. It gave a better ability to say, okay, here's the query that came back, and here's the answers that we could get. Going back to the interoperability and the future potential and working together, With that peanut butter and jelly article I did, I've had Matt and Glenn that have been able to hook up with the kids over at Bragg for their data point modeling. We've had 2022, SDMX, Bragg all on a call discussing how can we leverage these large language models? How do we work together? Because the models that we're trying to do and the stuff that we want to do is great, but we got to start talking. And that was the first step really of what we were doing for this. Finally, on the outcomes and where we kind of got towards, frustrating, painful, don't want to do it again. You know, my mother, excuse me, you don't, but my mother was funny. She goes, doesn't large language models fix everything? I said, no, Mom, no, it doesn't. But to the point, the research that needs to be done on this is going towards the NLP side. And one of the things we found is, ironically, it was Amazon, Alexa. Ironically, the team that created the Alexa winning prize is based in Prague, Czech Republic, where I am. So we're talking with them, with their NLP guys to go, okay, let's look at it from that standpoint. We'll figure out this other stuff as we go along. One other thing, I'd like to thank NVIDIA. They really were kind of digging what I was doing, and they've offered $25,000 in credits to train future, yeah, I know, thanks, to train something. And they said, we don't understand fully what you're doing, but we'd like to help out. So working together, something is really important in developing this. The other thing, one other thing, real quick thing is open source. There were certain aspects of what we were doing, especially the metadata stuff. We feel that leveraging the FMR, we could put more metadata in there that would help with these large language models. A lot of them didn't know what the hell they were doing. They were like, there was no context, what's this, what's that. So if there was a way to do that in an open source kind of environment, that would be very beneficial. And we were looking to kind of start to create that, to take something kind of what Brian's created, to where it's an SDMX bot that goes out and is able to pull down the code list and populate the FMR to then train the large language models. And we saw that with some benefit as well. Yeah, that's not my real address. That also was AI generated, and I had to do that. And the funny part about this is, and I will leave it with this, we think we can type a prompt and something magic's gonna happen. And it does. It's called BS. And a lot of people don't know the difference. And what we're trying here is to try to get between that and the actual reality of what we've got. And that's the challenge. So thank you for all your time. One thing I do want to thank, again, everybody that was doing this. This wasn't my presentation. This was all of ours, because this is a very complicated topic. It's just not about interoperability. It's about actually having and making sense of what you're delivering. So thank you so much. Hey, I did 15 minutes.
Thanks, Tom, for this very inspiring presentation. I think we need more of this, yeah, because it's a complicated topic, as you say, but as I mentioned in the beginning, there's a lot of demand actually for that from various organizations, from sponsors, yeah, to invest and to basically overcome the complications which you have just mentioned, yeah. And it's good to see that you know, many people like you look at this from a quite different angle, and I'm sure in 1 or 2 years we are probably more advanced, hopefully.
From a commercial standpoint, I mean, we love SDMX. Again, I tell my mother SDMX and she looks at me like I got a hole in my head, but the point of the matter is that the core of what's developed and leveraging that into what SmartX is wanting to do, it's important. But the third thing, it's getting people to know about SDMX. And with NLP, hopefully my mom will be able to talk to SDMX and hey, how many coffee beans are made in Colombia this year, and she can get that information. But if we can work towards that common goal, I think we got a chance.
Absolutely agree. All right. Any questions at the moment? Please.
Yippee. Uh-oh.
Okay. Question. I couldn't help to notice, so you are talking about interoperability between evolving technologies or standards like ISO standards. So how do you then ensure that you have like basically interoperability at a point in time, like given that these are evolving things over time, like so just more about. captured at that point in time that you are doing it? How does someone go back in the future and say, well, this is what this was at that point?
What's the joke? The best thing about standards is there's so many to choose from. That's a great question, because in what we found, there needs to be a standard metadata repository with a persistent identifier that allows for today and tomorrow. That's it. The interoperability about standards is never, ever going to happen. Only thing we can really do is to go, okay, what do you name things? What is it? Let's start there, and then the rest will work out. The tool that I used here for 2022 was created specifically for 2022 to do things. Everybody within their standards, everybody within their field are creating tools to help their standard do the stuff. Let's cheer that on. Let's don't try to squish what they've got. Let's take what we need out of it and bring it over here. Thank you for that question.
Thank you. And we have time for another question. There's none. Maybe just one question from my side. I mean, we saw this also a little bit in the first presentation. At the end, what you need are these different agents, yeah? And especially when it comes to things which need to be 100% correct, yeah? You need to query an SDMX compliant API, but you cannot rely, let's say, on a generic NLP agent. That's also what we saw actually, from Alex's presentation when we did the POC. In the first part of the POC at the BIS, we actually tried to implement a bot which gives some answer to a question from a user, and let's say in 10% of the cases the answer was actually wrong. And we said this cannot work for an international organization, it needs to be super correct. And then what we did in the next step is we actually implemented this other agent which was a filter assistant. So we basically get a question and then we propose a filter and we just say, is this corresponding to the question you had? But we don't give an answer to the question because this might be incorrect.
I'm not a big fan of synthetic data, but I think in this particular instance, you might be able to create a lot of the answers ahead of time and populate that in the model itself. But again, scale down, not up. There needs to be, it's the organization's tinyml.org, and there are a bunch of academics that are promoting this. And to get that kind of concept, if you can break it, the smaller you go, the better odds of you overcoming the challenge than scaling up.
Yes, fully agree, yeah. Okay, perfect. Thanks, Tom. That was very inspiring.
Thanks so much.
Let's give Tom another clap. Okay, and we arrive at the final presentation of this first session, which is the chatbot initiatives I mentioned, where we basically use AI in order to query SDMX technical documentations and guidelines. And the presentation will be given by three colleagues, Julian, Samuel, and Brian. So Julian and Brian are here physically, so please come already to the front. And Samuel is remotely logging into the session. Now, Julian works since 7 years, and please, Julian and Brian, you can already step forward. So Julian works since 7 years with artificial intelligence, and he's currently leading an experts group at the company HMS Analytics, a company which we work with since 20 years. And he is basically running a little AI team at the BIS at the moment. Then Samuel is doing his master thesis on this specific topic, which I just mentioned. And Brian, many of you know, as he is actually one of the oldest SDMX experts we have here. Yeah, since 20 years he's working with SDMX. So really a treasure. And initially he collaborated on the UN Millennium Development Goals project. And he also worked on the reporting of SDMX compliant data for the UN data portal. So welcome the three of you, and we are excited.
Thanks. Okay, great. Thanks, Rafael. I'm really happy Julian's train got here, so that was a bit of a stress, and that Samuel's microphone is working, so I think we're all good. So happy to be here presenting, and welcome to everybody online. So BIS is exploring the application of AI in multiple areas. I think Rafael's given a great overview of that already. And recent surveys have highlighted that lack of knowledge is a common barrier in the adoption of SDMX. So one of the AI sessions or AI projects that we wanted to take on is actually looking, can we use AI to actually address this knowledge gap from an SDMX point of view? So in this presentation, we're going to do an overview of AI in general at the BIS, the projects Julian's been working on, and then specifically deep dive into the chatbot. All right. So for a quick overview of the chatbot initiative, we've ingested all of the SDMX technical documentation into a chatbot. So there's one SDMX expert that's going through and has tried to model the types of users that would be interested and that this content would be relevant to, such as methodologist, statistician, an IT person, standards expert, so forth. And then developed 100 questions from the documentation to just use it as a QA approach. To see if the chatbot is actually giving us sensible answers whenever we're using it. So going forward, what we're looking to do is to see from a sustainability perspective, can we reduce the demands on experts to actually be reviewing these outputs and quality assuring the chatbot? Can we maximize the appropriateness of responses to the role of the people that are effectively asking the questions? Because what an IT person wants to hear versus a methodologist versus a standards expert are completely different. Can we maximize the relevance of responses as well? And so have the stakeholders start to actually specify whether this is meeting their needs or not and feed that back into the process. Expand with additional content types. There's a wealth of great information out there from all of the past global conferences and experts meetings and the e-learning courses that have been produced, et cetera. So it would be really nice to ingest that and be able to actually factor that into the feedback that the chatbot is using. And then how do we make this predictable from a cost perspective so that we could actually think about going public with it? And with that, I hand it over to the guys that have really all the interesting things to say.
This is our next slide, right?
Yeah.
Perfect. Thank you guys. I'm very excited to talk about this here. So in general, SDMX does play an integral part in several of the Gen AI applications which are the BIS. And the relevance for future applications, of course, is likely as a lot of data is based on that. Oh, I'm very sorry. Yeah, so as I said, the SDMX, of course, does play an integral part, just as the nature of the data. In several applications we have, and the relevance for further applications is very likely. So I brought you first as a couple of software that is already productive, that is already being hosted, right? That is already being used. The first is a metadata AI editor. So inconsistencies are often a problem, and they are a pain for the users. Also, it's a lot of work to fix these errors, and it's error prone. So there is a tool that solves this issue. What you can see here is basically the first page. It's kind of a sort in. You bring in your data you kind of want to integrate. You get all the modalities right you kind of want to happen. And then this tool is really simple. And I think probably you SDMX people will appreciate it more than I could. But it automatically goes through and proposes changes to make it align with the metadata, right? How should dates be formatted? And all that kind of stuff, right? And critical though, this is not an automatic tool. It still requires user interaction. It just makes it a lot faster. It just proposes changes, and you can either accept them or rewrite them. Another tool is we already have a RAG, retrieval augmented generation, so a system that uses the SDMX documentation to chat with you. And it can do several quite cool stuff already. So this is based on the question, what is the difference between JSON and SDMX? And it first gives you an overview of different data, documents it found. It also gives you an analysis of how relevant it thinks these sources it found are. And of course, it gives you a plain old answer, right? Yeah, and that is already all running. But there are many different applications in the BIS environment and many different RAG applications, and the state of art is expanding at a rapid pace. And instead of building individual applications for every user group, right? Every committee, every stakeholder. We focused on a more central solution with high software engineering standards, at least we like to think so, where we split basically everything into repeatable components. This is very done by a lot of people right now. It's often referred to as multi-agent system or collaborative agent systems. The idea is that each individual repeating pattern in a software, such as producing mathematics, for example, you isolate in its own microservice, and then you just plug and play them together. There are multiple benefits. First, each individual component can be much more specialized. You can customize them exactly to their needs, but you can also customize each use case to only use the components it does. It scales a lot better because individual components can be changed and upgraded as necessary. For example, say there's a new database or a new LLM, you just swap that out and the rest of the system will hopefully align, and often does, which also leads to cost efficiency and consistency, right? Because pretty much if you look at tests or validation between different systems for the same components, it will be the same, which also increases interpretability because you can really go step by step. How does this look like? Often this is also shown as a graph. It has two further advantages. It also means that code size and context length, right, the maximum number of documents you can feed into a system stays linear. So you get often even faster answers. We are a fan, however, of chains instead of agents. Agents are systems which basically call themselves until they have found an answer. A chain is a very specific set, right? To make a cup of coffee, you first boil coffee, then you put coffee powder, then you put it in the machine. And for most stuff where you kind of know what you want to do, this is vastly superior, and you can still plug an agent at the end of a chain. So how does this, for example, look like? We have our reusable AI components, for example, from summary generation to sentiment analysis. And here I completely agree, you often don't need AI per se. A lot of these tokens don't need to be AI relevant at all. And we have different data sources, and we just plug and play. For example, for a more sophisticated RAG chatbot, you see how this is, how there are multiple components coming together. But for something like just giving a researcher the opportunity to do sentiment analysis on surveys, a very simple, straightforward chain will do. And for this architecture, which we are probably launching in a month or two within BIS, we are also doing a specific token for SDMX, and that is the very exciting topic of the master thesis of Samuel, and I'll give it to you and explain what you're doing.
Yes, I've just been told that you can't see my face when the presentation is there, so I will share it for myself.
No, we can see you.
Oh, you can see me, okay. So then
okay.
I don't have to share it.
No, we can't.
Okay. Okay. Okay, well.
So we see the slides and we see your cursor.
Okay, well, then just let me.
If you can't face the slide, just say when I should
sharing. So everything is okay now, and there's your slide. So I'll just talk over that.
No, I think it was better before. You shared the slides. Now we see you again. Yeah.
Okay, wait. So this is good.
Yes.
Yes.
Yeah. Okay. So let's do that. Okay, so I can now give you a little glimpse into my master thesis. This is still ongoing. I'm at the halfway point, so it's very much a work in progress. And you could summarize my goal as researching how to make this SDMX chatbot great. How can we improve it? There's also already an existing one. How can we make that better with this specific use case? This is all based on the publicly available SDMX data documentation. We can expand that later. And here are a few documents listed. You probably know them a lot better than myself. Those are the experiment data set. This is the documents we really focus on, and then when the methodology is really sound, we can scale it up later. The first step is always to get the data out of the documents, and that's not always easy, especially with PDF. That's always quite a struggle. And for example, one thing you might know if you see these documents is that they have line numbers. And when you get text out of the PDFs, those line numbers go absolutely everywhere and you have to filter them out again. And also these documents are really structured. They have headings, subheadings, then paragraphs and lists and tables, and we really like that structure and would like to hold onto it as long as possible. For this purpose, I found this tool called LLM Ingester. It's a bit niche, but it has some really nice features. It uses heuristics based on the layout to group together what is together, and can also do some additional things, provide context for the LLM, which is interesting to experiment around with. You can see here the output, this JSON, that's what the modified tool, which does all the things listed above. And you can see it's quite nice, you can see the text there and it's quite readable, and that's what we want. Also, what you can do within this data preparation step, that is something that already exists in this existing chatbot, is get metadata, so that the user can decide, hey, chatbot, please only reference documents that are of version 2.01, for example. That's something that already exists, and that's probably something that will keep existing because it's really, really useful. Then one thing I really focus on are citations, because they are great for providing more transparency. It's nice to know that the chatbot has all this documentation in the background, but we really want to see how it uses it, just to be sure that it actually uses the right one. And citations also make the documentation better, because if you have a question and it gives you the answer and also where you could have found the answer, now you know, now you have a better understanding of the documentation. That's the good part. The bad part is that LLMs aren't really perfect with citing. There was a study done on the big chatbots like Bing Chat, for example, which has citations, and if humans look at it, they usually say 40% of the time, you know, that claim and that citation, they don't match exactly. This isn't proven 100%. So to start out, I did a little analysis. Brian already mentioned these 100 questions. I threw a RAG system on it and asked it to cite. And this plot here on the right is the results of that. What we want to see is the blue to be really far on the right and the orange really far on the left. We want the good stuff to be cited and the not so fitting stuff to be not cited. And you can see it already works quite well. You see two orange bars very far to the right. Those are headings, and that was the moment I realized that GPTs really think that headings prove a lot more than they actually do. So that was the point. I had to filter them out, and now that's one thing that's fixed. One thing I also noticed at this point was when I experimented with smaller models, is that they really struggle with citations, especially surface level things, but that you can combat this with simple string processing. So they fail with formatting citations, but always in the same manner or in a few different manners, but you can predict it and fix that. So that's an interesting trade-off there. But I think we can even do better than this. And for this, I need to introduce you to the Raptor paper, which is a really nice paper. And it introduces a very simple idea. When you have these pages of PDFs, you can ask a GPT to summarize each one, and you get a smaller paragraph. And then you can group together a few of these paragraphs that fit together semantically, and you ask a GPT to summarize those again, and you do that for all of them. And then you do that over and over again, and what emerges is a tree structure, because you get smaller and smaller. And trees are always nice, but we can now enhance this tree. For each of these paragraphs and sections of a page, we can ask a GPT to generate questions. So what does this paragraph answer? And with this, we get a representation of the knowledge that is in this summary or paragraph. And now that we have these two, we can put them together, and we get this tree that is really abstract at the top and goes into more and more details the longer you go, and also has this question attached to it, so we can have a better understanding of what is the level of detail here. And with this tree, we can solve citations quite elegantly, because this, with a bit of graph theory in the background, then in this case, citations are just subtrees now. We can go ahead, find a subtree, and if we keep the metadata, we can see, okay, this subtree, these are the documents in the subtree, and these are the pages here. So we know this question, for example, is answered by these documents on these pages. It also makes search better, because we have now questions that the user asks and questions that we have stored in this tree, and now we're comparing apples to apples, and that's always better. And then, of course, a lot of open questions. What do we do when a question wasn't already in the tree and the user asked it? How do we deal with that? So it's still very much a work in progress. But I think it's really useful, because we can have this tree and provide it for other tools or other chatbots. We could just publish this tree in and of itself as a website with some editing, and then you could just read it and find your questions there. And it may even just improve the documentation itself, because we can see what questions does this documentation answer and where does it answer them. Are questions scattered around, or are they really together in one piece? And maybe we can see, okay, maybe we need to group that a bit together more. And with that, I'll give back to you, Julian.
Yeah, I just want to express that we are very willing to share our experiences, and I think maybe even code structures such as this tree if it's done. Yeah, just come say hi.
Thanks, yeah. So that's a really exciting project. Are there any questions?
So thank you for the presentation. I think it's really interesting, and I have a very strong vested interest in this because I mean, I'm not sure how useful this will be for the general public, but you know, in our SDMX team, we always have new people. It's difficult to get them trained. They often have questions, and they need to ask the experienced people, and it's easier if they just ask a chat box. So I have one question and one remark. The question is it something that would be available outside of the BIS, or could be made available outside of the BIS, this kind of chat box that you have developed over the SDMX documentation? And then just the remark, I think was very interesting what was presented about the kind of transformations that needed to be made to the documentation to make it AI friendly. We have an ongoing project that we are financing to remake the SDMX documentation in a more easily searchable fashion. The idea there was to make it more searchable for humans, but I wonder if as a community it wouldn't make sense to try within that project to also include something about making it also AI friendly, which to be honest I had not thought about until 10 minutes ago. So yeah, that's it.
Maybe I answer the first question. So initially the idea was to bring this to sdmx.org. And of course there are several steps to be taken. We need to have a review, test it, you know, similar what we do for StatGPT. Also needs to go through legal and internal risk assessment and so on. So I think there's still a way. Now, we could, however, already at an earlier stage make it available, for example, in a, let's say, in a test environment or even the software. So, you know, basically you take then the risks, yeah, we give you the software and you can experiment already with it on your side if there's certain urgency, yeah. So, but again, the idea is to bring it to sdmx.org as a chatbot and also to make it open source on the BIS open tech site. So that's basically a site, an innovation site on our website. Now regarding the second question, yeah, absolutely. I think I didn't know about this initiative since 10 seconds ago. So I think it's very important to have these type of initiatives, and this is exactly what I mean with collaboration. If you're anyhow investing to improve, for example, searchability, let's work together and see what we can actually then use for that project. So we will reach out then bilaterally after the meeting. Yeah. Okay. Anything else you would like to add, or no? Okay. I have seen two other questions. Maybe let's take one more question and.
Thank you for your very interesting presentation. I have seen that you have made a lot of efforts on citations because they are very important to see the reliability or the context of the answer. But my question is your model going to be able to provide examples? Because I think that this is also something very important to just clarify the answer and to be able to ask the model about if he can give a specific example on how to delete an attribute at a group level or things like that. Thank you.
Okay. Oh, Julian, do you want to take this?
Go ahead, Sam.
So for my part, currently, sadly no, but that's also due to the nature of the documents I'm working with, because those are the more general documentations, and it's a bit hard to. The examples are very specific. So at least for the duration of my thesis, I don't think so. Afterwards, I think that would be a very interesting direction, and could even. I think there would be ways to integrate this into this tree structure I presented, and would be a really interesting thing. And especially one thing that's nice about this tree is that you can edit it manually. So at some point, if you see maybe on crucial parts you would need examples, you could provide them manually even.
And to add on to that, of course, even in other applications outside of STMX, we are always striving to do that. It's more see it as an iterative process, right? First, be really good at find the actual ground truth if you're working with documents. And then, of course, doing examples is something that is often interesting, clarifying answers. And there are various degrees of how good you can do it, depending how hard the task is. But usually a lot of stuff works out of the box if you have good ground truths.
Thank you.
Thanks. Okay, Maxime, you had another question? And by the way, I just wanted to say, now we have the open Q&A session, so you can also ask questions to the previous speakers, yeah?
Thank you. The question is regarding this approach with multiple summarizations. How do you actually... So the evidence problem with summarization is that you can lose some parts of the information. So you do first summarization, you lose parts of the information, then you go even further. So how do you validate that your actual results on every step of this tree is valid in the sense that it does not lose too much of the information, that it has all the valid and relevant summary to your to the chapter, to the parts of the document that you are referencing in this part of the subtree?
Yeah, that's one of the most central problems. One thing that's really nice is that because we generate these questions and we need to do a little bit of fuzzy matching or comparison between two questions, you have a very clear understanding of where information is added and lost. So you can see here's the question answers, you go up, the question is answers, and then the question isn't found anymore. So this is the point where this detail was lost. And then I mean, we want details to be lost, and it's quite hard to really, I don't know if there's really a good way to define it that you could check automatically whether details should have been there in the first place. But
I'll take it from this step, Sam. Then he can't know that because this is not part of his research thesis. But the problem you're referring to, right, is going for it's basically the same for, this is just an index, right? You're searching documents and you're at the same point, just that this is a contextual rather than a semantic-based search index. And within our wider system, we have evaluation metrics such as faithfulness, where from a test set you look, does it use all the documents it should have had to answer the question, and a lot of other stuff, right? There's like a lot of contextual based evaluations you can use. And this system, you just evaluate it how you would evaluate any other retrieval system.
All right, thank you.
Right. Do you have another microphone at the end? Good. Please, Jens.
Yes, thank you very much for the presentation. So my question is, I guess, a bit related to the last one. So you mentioned that SDMX experts are needed. I think the context was, some part of quality assurance. But how much are subject matter experts actually consulted on the results of such a tool? So for instance, I guess our national accounts team, but other researchers, they would be quite concerned if users were being kind of, sent up like wrong summaries and I guess hallucinations. So yeah, how much are subject matter experts actually, consulted on the results of such tools? And I guess this, this could be for your presentation, but also the other presentations. Thanks.
Yeah, well, I guess I would say that at this point, it's early days to start, but also that in going through the technical documentation, I don't recall a lot of subject matter content in the documentation that's there now. So it's not an issue per se at this point in time. As we move forward, just as we're having the experts in the content that's there now review that content and validate that the model is being effective, as we extend that content into other areas, we would bring in the other experts to have to validate that as well as part of the process, just to be able to sign off and say we're getting accurate responses.
Yeah, maybe Jens, this is a super important question. Maybe I can also pass this to you, because in StatsGPT, I think you mentioned also something in your presentation that there were some concerns, and maybe you can just elaborate a little bit how you expressed this, Jeff.
Yeah. So I mean, I didn't show it in the demonstration, but on the knowledge-based type questions, we prioritize documents that have been uploaded from the international organization. I didn't produce the list, but there's, I think, 10 documents that we uploaded into the system. So if the agent recognizes that this is a question pertaining to content in those documents, it prioritizes the answer from those documents. And it references a specific paragraph, so the chunk of where that answer came from. And so part of the testing phase we're doing is we're hopeful that when people ask those knowledge-based questions and they see the responses and don't like them, they tell us that this is a bad response. We have this sort of thumbs up, thumbs down, which is a really, really quick and dirty way of saying, well, no, this isn't good, or it could be better. So that's one thing, and I guess it's an interesting question. So imagine an answer that doesn't exist in the documentation of our collective organizations. Then what do? Well, you could say, this is beyond my understanding of economic and financial concepts, whatever that universe is, and stop there. Or you could go to sort of the wider GPT-4 world, and it's an interesting question about what your preference would be. So something like the misery index, well, it's not in any of our sort of glossary of terms, or maybe even the Phillips curve might not be, right? But that's a very nice entry point into the system to ask a sort of generic question about the Phillips curve, and the answer that the sort of LLM produces isn't bad. So do you want to prevent that, which may have more certainty on the knowledge base, or do you want to allow that, which gives you sort of greater sort of breadth of questions? So I don't know the answer, but there's a trade-off there, I think.
Yeah, thank you. Maybe there's some experience from another organization on this type of question, which you would like to share? No, not. Okay, but I mean, again, this is a super important question, and there are a lot of, let's say, safeguards built, for example, within the BIS actually to mitigate related risks. So, for example, there's a difference if you publish these bots, within a certain experts group internally, or maybe within the international organization community, or whether you publish it on the public website. Yeah? So there are different measures. How much hallucination can you actually have, and which experts need to sign off, and so on. So, and for us, as you know, I mean, this is a super important question because trust is all. Yeah, I mean, we built this up over many, many years, and this can be destroyed very quickly. Yeah? So we need to be very, very careful. All right, thank you, Luca.
I have a more general question to all the presenters, but to the room in general as well. In the first presentation, I thought it was quite interesting. Okay, well, many things were interesting, but at some point you mentioned that you augment the SDMX metadata with some additional elements. And to be honest, some of those elements, I think they could be in the SDMX metadata directly. Like there was something about the frequency. I think we have a way to mark the frequency dimension in a data structure. And if we do it consistently, then it could be taken from the metadata, from the DSD, instead of having to be added separately. And then also, in Tom's presentation, he ended as well with a question, what kind of metadata is good for AI? and it's also something that came up a bit in the chat box, that how you had to format the documentation in this case. So, and I know that there are some initiatives out there beyond the SDMX world. I've heard about this initiative by Google, this Google Compass, which is about having some metadata in schema.org that would make things more easily understandable by AI. My question is, are we already in a position, and as an SDMX community, to start having some guidelines about how to best represent our objects to make them AI friendly? Is it something for which, so can we get, I don't know, the SWG or the TWG, I'm not even sure which would be responsible, to start thinking on that? Is it too early in this? If it's too early, what can we do to start gathering and collecting this kind of information so that when I make a data structure, I make a code list, I make it in a way that's AI friendly and increase the accuracy of any AI tool that will be working with it. So this is a general question, I would say.
You need to start now. From a commercial standpoint, how do we know what something is? If you're looking at it, the metadata is going to be, oh, sorry, I'm loud, don't worry.
I think it's more about the remote participants. Yeah, they don't. Let me just.
Hello. Hi. It started now. Out in the real world, we don't know what the data is. We don't know what we need some sort of compass, and we use the word compass. A point of light, FMR, has been something we've been looking at to better understand what these things are. Without that, we're all kind of flying blind in a lot of respects. And to everybody that's been training their large language models, a lot of times the stuff that we're training on is bupkis. It doesn't have the right kind of things that we need into it until we get at the end, and then we got to retrain again. And that actually was one of the questions of, on your retraining, you said you had different modules. Did you have to retrain the model each and every time that you updated some of the data sets to it, or?
Oh, sorry, go ahead.
This was the question?
Yeah, just kind of in general, yeah.
Okay, so we did not. We had a choice, actually. How do we approach this? Either we try to standardize everything in a sense ourselves and probably be guiding us into this direction, or we just accept the things as we are. And we decided that, okay, there is still a lot of different ways of do this, and this might be a project by itself to actually do this level of standardization. So we just tried to accept things as they are, and we worked around that. However, I really adhere with the points that this is a very right moment for the probably statistical working group or technical working group to start thinking on these things. And I had a bullet on my presentation that many of the things that we we did additional metadata, they could be actually driven by SDMX annotations. And what we probably see from all the presentations today, that the domain is complex and there are a lot of problems to address there, just the problems of how LLM is working, how good it is in doing what it is doing. So if we can get the help from the statistical community just by this level of standardization, level of compliance, then it would just really simplify our task in a sense where we will not be dealing with this too much silos of different approaches to how you model your metadata. So the answer to your question is that I believe now is the time. We have quite enough of good understanding of what metadata do we need, so we can really start working on this and trying to find some standard ways to approach this. And thank you for the question.
So I think, Maxim, what would be good is maybe not urgent, but maybe at one point to have a little summary of, how should these objects look like in an ideal standardized fashion from your experience, yeah? And then submit this to Jens, to the SWG, and Matt, the TWG, and then we can see whether we work on a work stream there. Yeah? Thank you. Jens?
Yes, so it's David at the SWG.
Sorry, David.
Sorry, Jens. He sat there. Yeah. So I think it's a very interesting proposal. Of course, the SWG, I mean, we're still working on converging on the semantics, whether it's for AI or not, right? You know, we already have things like the SDMX glossary where everything is coded, the cross-domain concepts, the code list. You know, all these things are still being worked on and will continue to be worked on. But you know, perhaps a specific guideline for AI. If this is what's needed, if this could help, you know, perhaps this could start. You know, this of course will be, I think, a cross working group task force. You know, with the TWG. So yeah. I mean, we'll see a presentation from Yuri. I don't know if it's tomorrow or the day after on unit of measure semantics as well and the methodology. I think this could help as well. Perhaps. So yeah, it could be a very interesting proposal. I think, especially because, you know, I hear all the kind of issues and the request for something like this, you know, from this session. I don't know, Matt, if you want to say something as well. Or?
Thanks. Well, it is Matt from the TWG, so that was correct. I think we asked the question last year in the TWG to EPAM, I think, actually, of is there anything that we need to change in the technical standards to better support AI? And I think by and large it was kind of okay generally. But the question is open forever, right? It's kind of like, because the purpose of the TWG is to evolve the standards to make it usable by applications. But I am doing a presentation tomorrow, which I'd be very interested for feedback on, because it is talking about the problem of mapping metadata, which I see as sort of, you know, because when we're talking to, say, Google and their data commons, it's all about mapping and creating relationships. And I'll be very interested to get some feedback on that from the perspective of the AI community.
Maybe I just wanted to add maybe one thing, yeah. And you know, I think there's another presentation tomorrow on sort of, we're looking at it from, you know, extracting the SDMX out using AI, but I think we'll get to a stage where you could use AI to do the modeling as well, right? And then maybe that AI is going to solve its own problem, right? So, you know, you're going to have the modeling structure that you need.
Yeah, I think this may be a bit of a stretch at the moment, because this is my opinion. I mean, because in the modeling discussions I have, quite often they take a long time, and this is with the actual subject matter experts, you know, really trying to unpack the characteristics of their existing indicators. And, you know, I was in a discussion recently, and it took half an hour of discussion to actually, you know, unpack what the denominator was of this particular indicator. So, you know, when it's the actual subject matter experts and they're unsure, then I'm not quite sure how AI at the moment, you know, could really infer something when the metadata itself is kind of flu. But yeah, I guess we'll see. Thanks.
Okay, thanks, David. Julian, you had another comment?
Yeah, maybe one interesting remark. I hope I'm correctly reading the room, but I think a lot of the proposals are kind of coming from this idea of how can we make SDMX better to interact with AI from a way of making it better at the source. And if you want a real far-out talk about religion, philosophy, and quantum physics, I've had a talk, you can come to me, but the basic gist, what a lot of people don't understand about what makes these systems useful, Gen AI, is that it's contextual truth, not definitional truth. So, we notice in every life, people will not agree whether pineapple is an ingredient for pizza. And that is the most hard problem. I don't know if you guys agree, when actually building these systems, is who is listening to them, what kind of answer is he expecting. So when you think about how you can make it better, it's probably useful to let go of the idea of an actual truth at that point, and more also think of how can we make it more clear what we expect the system to produce, what do we consider a good answer to the question being asked.
Yeah, that's a very good point, yeah. Abdullah.
Yeah, actually. Yeah, actually, I have a question on just that. So, to a question to all the presenters, is there already, or is there an attempt to plan to link structural and to link data, and reference metadata in addition to the structural metadata? To try to use reference metadata to provide more nuanced and more precise answers to the user. Is there, if it's not supported now, is there at least a plan to support that in the future?
Anyone who wants to take the answer? Maxime?
This is a great question, and we've been looking into it. And the real challenge, like technical challenge, that we get is that at some point, too much of information could also start confusing the LLMs as well. So there is a trade-off and a balance between. So what we did during one of our experimentation phases, we said, okay, let's not only include names to the search, but also include descriptions, which gives us probably a better understanding of semantical thing. And by that time, we observed a decrease in results as opposed to what we expected to have an increase of the results. Just for the reason, so when we debugged this, the reason for this was that it was given too much, so too many things could click in this description that would attribute this particular thing to another domain, just because the description would be that comprehensive and include that many information that by that time it becomes unsustainable. So far, there is clearly a way for us to explore how much more metadata we can add to the play, and we need to stay conscious with the respect that it needs to be, like every hour edition, we need to check it really thoroughly with respect that it really gives the increments and not the decrements to the quality of the results.
All right, that's an interesting point, yeah. Status, I know you have a question, but maybe can we maybe park that for, let's say, after the next session, because we have actually a little survey which we also want to run within the next 20 minutes, and I would like to reserve that. And I think we have enough time in the breaks then for further questions, yeah? All right, so thanks again to the speakers.
Thank you.
So maybe Glenn, if you want to come up here and give a little introduction.
Yes, thank you. So we've got to the best bit of the session now, so we get to try out Slido for real. As we have the experts assembled here, it'd be really helpful to actually get some feedback, particularly from obviously the presentations that we've already seen, but to get some sort of collaborative understanding of where the opportunities lie for AI. Obviously, we've seen a diverse range of presentations. I mean, for me, it really struck me that still working months since ChatGPT dropped. So obviously, you know, and the pace of development and the pace of the use cases which have actually been developed is quite astounding. But I think where we are now, it'd be really helpful to get a really good understanding from the group here and online as well, particularly where the real opportunities lie. And for me, you know, it may be something about, wouldn't it be really cool if I could use a LLM or a chatbot or something to reorganize my code list, something else like that, you know. So this is the sort of thing we're thinking about. So we have 4 questions, 4 Slido questions. So maybe we can bring up the first of those questions, and just to give you an insight into what they are.
No, but it's the first presentation, the one marked 1.0. Then for the slides.
Okay, so it's just wrestling with Slido into... So while we're waiting for Slido to come up, then I'll just sort of outline the question so you can start giving it a little bit of thought. So the first one is about the opportunities to enhance.
To go through the last slide.
Perfect. Okay. Yes.
Question, and then for the slide itself, I will comment.
Let's do that. So move forward quickly. There we go. Right. Yes. So you can start thinking about it very, very quickly. So the first one is about opportunities to enhance the statistical life cycle. So reporting, collection, production, dissemination. So where you see the opportunities in there. The second is about AI in SDMX and data management. So the wider context here, maybe data governance, these sort of additional sort of things outside of the standard life cycle. Third question is about, again, opportunities, where you see the opportunities lying to enhance the usability and application of SDMX using Gen AI. And of course, the SDMX chatbot presentation we saw just now obviously sort of fits very well into that category. And then finally, collaboration strategies, how we can best collaborate to move these forward, because obviously working together on these things will potentially provide a better result and potentially a quicker result. So last thing, while we are, Luca's valiantly wrestling Slido into place, the first three questions are ranking questions. So you will be able to select one or more answers and rank them in order of preference. What we're really looking for is not sort of everything, but where you see the main opportunities lying. So let's go to that. Okay, so here we go. First question, opportunities to enhance the statistical life cycle. So 7 options, hopefully everyone will recognise the main parts of the statistical life cycle. So if you go to slido.com or scan the QR code and then rank where you think the top opportunities lie. So obviously we've seen a couple of presentations on dissemination. There we go. Okay, we're already getting some good results. Adjusting. So this is quite interesting. So I thought dissemination is winning. Okay, so wait a couple of seconds in order to sort of stabilise it, let everyone have a chance to complete their votes. Okay, so maybe that's largely stabilised. So interesting result there. Obviously, the dissemination coming out on top. I think we already probably knew this was probably a really interesting and sort of valuable use case as such. Process, really interesting. Editing, classification. Can we just get a quick show of hands as to who chose process? A lot of people. Is there anyone with a particular use case you'd like to share here? No one.
Yeah, maybe just to mention. So one use case which also was presented in the last presentation is this metadata editor, and just to give you one example. Quite often when we get submissions, the name of the institution does not match our internal definition of the name. For example, a central bank might be slightly misspelled, and so what we actually do is we have a list of the official names of the central banks, and we match them against the names which are provided through the submission. And then we have this little tool where we do manually the corrections. But basically the AI is helping us to identify where the mismatches are and highlights it. Yeah? So that's one example. It saves us some time. It's simple, but it's useful. Luca, you had another example, or?
Yes, I had just one for the processing. It's not really related to necessarily SDMX, but it's coding and imputation of incoming data. Sometimes when you get the microdata from Cisco units, they may have coding mistakes, or sometimes you want to do some imputation when they're missing, and that's something that, at least in Eurostat, some units are looking at, though for the time being it's not really based on SDMX structural metadata. Could be, I guess.
Okay, perfect. Just one, yes, because we need to carry on, but please.
Yes, thank you. One other case in statistical office in Indonesia is not like it, that they are using AI for classification, especially to codify for economic survey. And also they are collecting many data coming from different sources, sometimes the same company having different names or different addresses, so they are to match these companies using AI. Thank you.
Perfect, good. All right, so probably not unsurprising that the disseminations on the top of processing really interesting and be helpful to drill into that a little bit more detail in another forum. But as we're running a little short of time, next, let's go straight to the next question then. So again, opportunities here. So opportunities in data management. So a little bit more broadly, perhaps cross-cutting here. Thought of a few here. Maybe there are others. Obviously, sort of data governance is high in many organisations. Agendas here. Again, where do you think the opportunities lie here? Oh, very swift response. Okay, so looking fairly evenly matched, metadata management, harmonization, data modeling. I mean, in fact, the things Jeff mentioned, there's a presentation tomorrow, I think actually on utilization of AI for data modeling, so this will be very interesting in this space. Okay, so I think we're virtually stabilized there. So yeah, interesting results. So fairly evenly matched, harmonization, metadata management. Actually, interesting, we've got very few others there. So maybe there are no other ones. Maybe these are the key ones. Okay, good, interesting result. Let's move on then quickly. Thank you, Luca. I remember how to do that. So third question, again, opportunities, same format, but this time usability. So as we said, the chatbot that we saw earlier was obviously a key example of this. Maybe there are other examples, maybe other things we haven't thought of yet. Oh, interoperability is leading. Actually, reasonably level. Reducing the barriers to entry. Okay, leading. Okay, so I think we're virtually stabilised there. The one that strikes me there, I think is number 3, new applications for SDMX in the AI world. Is there any examples of that? I mean, for me, this was about where sort of SDMX can now take on new roles beyond the traditional statistics roles actually within AI. No specific thoughts? One, please. auto-generate essays? Essays, yeah. Okay, for research purposes or for?
Either for research purposes, either for the general public, I mean the press. For example, in many finance newspapers, you see analysis driven by data. So in your, let's say, application would be like generate those kind of reports, those kind of analysis, driven by those very ethnic data.
Okay, so generating a narrative, textual narrative around SDMX data. Yeah. Okay, thank you. So in the interest of time, let's move to the last question. Thank you, Luke. Right, so last, this is actually a multi-choice question. So pick 0 or more, or 1 or more perhaps, collaboration strategies. So this is how we can best, as a community, collaborate to move forward the whole AI space. Oh, everywhere. Okay, so sharing use cases and sharing of information. Again, fairly evenly matched. Excellent. So I think we're probably stabilizing now. So yeah, sharing use cases, sharing code. Coming out top there with the others, pretty evenly matched. Collaboration, experts from other institutions, yeah. Okay, so I mean, it shows, I think that there are a range of opportunities here, and particularly, obviously, collaboration with between experts, co-investment as well, more workshops. That'd be helpful. So this is really helpful data to move forward and to work out how we can actually continue with the collaborations. I think apart from anything else, obviously, having a clear focus of where we want to go and how we're actually going to sort of achieve that together is very helpful. So
super. Thanks, Ben. Very good. Okay, so maybe just to conclude, 2 observations here. One observation is related to the first question. So dissemination data discovery is obviously the most interesting topic where we believe AI can really make a difference. And I think that, again, shows that our cooperation with the IMF on StatsGPT is actually the right direction. So we go into the right direction. And I'm pretty sure that over the next couple of weeks and months, we will have a lot of, let's say, excitement. And the second observation is, so on the last question, how can we actually collaborate further? Sharing code use cases. We believe this is a very important topic, especially for the SDMX.io page. And Brian will give a presentation in the next days on SDMX.io. But there is a plan to add another, let's say, area in SDMX.io, which allows data scientists to publish use cases and relevant scripts or source code, in addition to the, let's say, larger application source code, which we already have on the web page at the moment. So we are currently in the setup phase. There is a workshop or conference in February in Rome from the Irving Fisher Committee, IFC, for central banks, but also statistical offices and international organizations are invited. Many of you are participating there. And the plan is actually to approach some of the colleagues who will give presentations there, and at the moment we have almost 100 submissions, to approach those colleagues who have an SDMX-related topic to actually prepare a use case and maybe even a code snippet to be published on SDMX.io so that we can share this as a public good to the SDMX community. So this is in line with the last question, with your answers you gave in the last questions. So we are working on that from a secretariat perspective, and there are many more things to come. But with this, I think we're all hungry. So I would like to thank again the speakers for this very exciting session.
So once again, in case you're wondering, lunch should be served downstairs.